So a couple people wrote in on 2. Some people with all of 2, which I'm not going to do all of 2. If you still need to see more after the fact, you can sign into office hours tomorrow. But I'll do 2A because that one came up a couple times. And one word to the wise. If you are spending more than 45 minutes on this, you need to stop, okay? Especially if you keep getting the same answer. Now, I haven't looked at this one yet, so I don't know if this is true for this one. You keep getting the same answer, and it doesn't match the bottom of the paper. I'm a human. I make mistakes. So sometimes the bottom of the page answer might not be right. It doesn't happen often, but it could happen, and wouldn't that be a shame for you to spend an hour? It's just not practical. So if you're spending that much time on it, you need to cut yourself off. If the bottom of the page is not just lining up and you've tried it 2 or 3 times, you've done a great job for trying 2 or 3 times. Send in the question and be done with it. Okay? So there's no need to do that, especially because, God, that would be terrible if the answer was wrong at the bottom, honest mistake, and that much time was wasted. But 3x squared minus 5, we're plugging in negative 5, so 3 times negative 5 squared minus 5 over 4x plus 10, so 4 times negative 5 plus 10. So on the numerator, we've got 25 here. 3 times 25 is 75 minus the 5. On the bottom, we have negative 20 plus 10, which is negative 10. So we've got 70 over negative 10, negative 7. Josh?
Isn't that a division?
No, that's an addition sign. Okay, so there's another good reason. Like if you maybe you're misreading something and you just can't get it to figure it out, just call it a day. It's not a great copy for sure, but we don't really use that division.
That was messing me up.
Oh yeah, see? So and it happens. And again, like I said, sometimes the answer is wrong. But if you check your work once, check it twice, and you can't figure it out, send in the question. So something's very simple there. And then for part f of 0, 3 times 0 squared minus 5 over 4x plus 10. And on the top, we get 0 minus 5, which is negative 5. Oops, I forgot to plug in my 0 on the bottom. And then 0 plus 10 is 10, so we get negative 1/2 for part f of 0. So, order of operations there. 4 and 5 on the back, and I'll kind of go through all of this. I need my calculator for sure. So Ian invested $2,500 in an investment vehicle that is generated to earn 4% compounded yearly. The amount of money in his account as a function of the years T. So they give you capital A means the amount is in his account, and T is the number of years. And here's the equation they're giving us. So finding A of 0 and A of 10, I don't think was an issue for anybody. Just plug it in. What do the two values that you found in part A represent? So the fact that A of 0 equaled 2,500 meant that at year 0, there was $2,500 in his account. This is right now. Hi. Sorry. I'm just TV recording right now. That's okay. Yeah, bye. They should enjoy this video at home. It means at year 0, $2,500 in the account. The fact that A of 10 was $3,700.61 meant that after 10 years of earning interest, the $2,500 had grown to $3,700.61. So that's A and B. This is where people kind of commented was on the C. So let's see what happens here. Using tables on your calculator, determine to the nearest whole year the value of T that solves the equation A of T equals 5,000. Justify your answer with numerical evidence. So this was kind of like the notes yesterday where you would go to your y equals, type in the equation. So we get 2,500, 1.04 to the x power. Okay? So from here, maybe there's a good spot. You want to go to your table setup. So second window. And we don't want our table to start at a decimal, that's for sure. So let's have it start at year Well, we already know at year 10, it's only $3,700. So let's at least have it start at year 10, and we'll change by 1 year at a time. So now when I go to second table, I'm pretty much scouring this Y column looking for when it reaches 5,000, and it's happening somewhere between year 17 and year 18. Does everybody see that? Which one is closer to 5,000, the 17 number or the 18 number? 18. 18 is only off by $64. 17 is off by like 130-ish. So the 18th year is the nearest year. Does that make sense? And when it says to justify your answer with numerical evidence, I would just, copy down that part of the table. 17 with that number, 18 with that number, and there's your evidence. Okay? What does the value of T you found in Part B represent about Ian's investment? That's the 18 years. It took 18 years to get to that value. And then 5, the graph, I think got people as well. So let's start this from scratch. A ball is shot from an air cannon at an angle of 45 degrees. It travels along a path given by this function. We'll probably type that into our calculator. Where H represents the ball's height above the ground and D represents the distance the ball has traveled horizontally. Using your calculator to generate a table, graph this function for all values from 0 to 50. So again, I'm going to type it in. And they say here to do 0 to 50, but I'm not going to do counting by ones. Plus X. I don't want, when I set up my table, I'll start at 0, but I don't want to count by ones and do 50 different points. That's ridiculous. I'll count by tens, so I have 5 points to graph. Okay? So when I look at my table, second table, I'm going to plot 0, 0, 10, 8, 20, 12, 30, 12, 48, and 50, 0. So this axis needs to go from 0 to 50. So I'll do 10, 20, 30, 40, 50. And you don't have to label every single one. So I scaled it and I have to label it distance. And on my y-axis, if I'm looking at my numbers, it increases to 12. It might go above 12, probably in between 20 and 30, because it looks like it's increasing, and probably turns around somewhere in between there. So I'm going to go like 0 to 20 just to be safe. So 5, 10, 15, 20. And this is going to be my height. So I'm just going to steal these points. 0, 0, 10, 8, I'm going to have to kind of estimate, 20, 12, 30, 12, 48, and 50, 0. Now, we've done enough functions and seen enough parabolas in our day that it doesn't just flatline here. There's obviously a peak up here somewhere. And I think that's what they're asking us for. What is the maximum height the ball reaches? So again, now I'm going to set my window so I can see this graph nicely. 0 to 50 and 0 to 20 we'll go with. And I'm going to hit graph so I can see an image of this. Okay? And then to find the maximum, again, second trace, which is that calc feature, is going to be our best friend, because on that menu you can find these top 5 options: intersections, min, maxes, zeros, and values. We want to find the maximum. So scroll down to maximum, and then your calculator wants to know essentially where's the window in between left to right where you want the maximum point. So I know my maximum point is kind of right around where it is, but I'm going to scroll to the left and make sure my cursor is to the left of the maximum. Hit enter. I'm going to scroll to the right and make sure my cursor is to the right of the maximum. Hit enter. And then guess, just hit enter, and my cursor will go right at the tippy top, which is at 25 seconds. We're 12.5 feet. So I can add that point at 25 seconds, we're at 12.5 feet, so something like that. So what is the maximum height? 12.5 feet. At what value of D does, oh, did I say 25 seconds? I didn't mean that. I meant 25 horizontal distance out. At what value of D does it reach that? 25. Okie doke? So calculator use, kind of really making sure we understand some of those features that we'll be using.